What's new with you today?
Um, been busy with GTC. It's been GTC, the NVIDIA machine learning conference.
Oh wow. Tell me more about it. Haven't heard of it. So enlighten me.
So I've learned about this thing called there's a program called Blazing SQL, and you can do SQL queries from CSV files and Parquet files. You don't actually have to load them into a database.
And say that one more time. What are you doing with the CSVs?
It's called in the conference or the Blazing SQL.
This Blazing SQL that you're talking about.
Blazing SQL is it's supposed to be like an accelerated version of SQL. It can take advantage of your GPU, but it'll also allow you to do SQL queries directly from CSV files.
Ooh. There are a couple data points in particular that I am looking for. And I was wondering if you may be able to help me get those out of those Washington State ones, because that Blazing SQL sounds like it's the right thing. The two data points I'm looking for are total waste, or I'll write this down too. But sorry to start writing you a laundry list, but essentially total waste by licensee by day. And there may be a couple different waste types, but essentially, so it would be nice to have the total for each type, but essentially just the daily totals. Because what would be nice would it be, oh, here's someone, Josh. I think. Welcome, Josh. We're just beginning to talk about some high in demand data points, but it's glad to have you join the group.
Yeah. Sorry, my speaker's on the wrong machine. That's interesting.
Well, I guess we'll dive back into this data points in 1 second, Charles. I've still got them on my mind. But I guess just welcome to the group, Josh. At the moment, we're just talking about Charles has discovered this tool, Blazing SQL, to basically help parse some of this Washington State cannabis data that we're working on. Just this big data dump, and some of the files are actually so large it's tough to manage.
Oh, interesting. So it's
Yeah, I've been doing a lot of experiments with Dask also, trying to get it to work with these files and stuff, and trying to configure it. There's a lot of
I've heard of Dask before. I'm sorry?
Essentially,
that one.
So Charles, you've got this big data set there of the date of, not even daily, of just every observation there is. And so, you know, as the cultivators go about their daily business, they're recording their waste. And so I think you said you discovered that in harvest batches, they're just creating waste from their harvests, essentially.
Right, that's why the waste is reported in the back CSV.
So if there's any way to essentially, you may know more about this than I do, some sort of aggregation query where you're summing up, you know, the waste by day and by licensee. If you could get that time series That's actually what the company I was talking about, Better Carbon Solutions, is looking for. So they're trying to break into like essentially the cannabis waste here in Washington. There's in other states like California, Colorado, and even Oklahoma recently. Cannabis waste is actually a big, or not big, but it's just small. It's a concern, and there's a dozen or so companies dealing with it. So, as they launch out, they're just going to need essentially a forecast of, okay, well, how much waste is even being produced? That way you can just sort of get a gauge on what you can do with it. And that's where the Cannabis Data Science group can help out, because one of the tools in my toolbox is forecasting. So give me a good time series and we can forecast it. So we've discovered this, Washington State cannabis data dump through, public records. And so now we're going to try to aggregate the waste by day.
Yeah, I started working on it at one point, and then I don't know, I got sidetracked.
Can you say that one more time?
I started working on the waste problem early on, and then I got sidetracked. Go back to doing that.
Yeah, and then it doesn't have to be that one. Like I said, really any totals by day, by licensee. The other total that I was interested in, it doesn't necessarily have to be by licensee, was I was essentially just wanting like a daily count of like lab tests, just to know how many lab tests are happening per day, and then once again forecast that into the future. But
So I need to publish that. What I found is that they don't record the lab tests like when they do them. It's sort of like, I think maybe some places maybe do it every day, like some places do it once a month or something. It's not, because I tried doing some students and work with
ooh. That actually reminded me. That wasn't actually the data point. The data point we were looking for was sales per lab result.
Okay. I think the sales are updated more regularly.
Yeah, see 502 data.
And so if you could do like the SQL on like the sales, so basically just do sales for global lab result X, and then I think it can be done because I think I've seen the data, but it's so the reason that data point is interesting is that gives you sort of, if you take the average of the sales per lab result, then that's basically the implied cost of a failed test. Because if you otherwise wouldn't have failed, then you would have on average, grossed that amount in the market.
Okay.
And so it's a crude measure, but basically, in economics, you try to measure all the costs, explicit and implicit. So we're trying to measure all the costs for cultivators, and one of their costs is the risk of failure. And the way you measure that cost is actually by their probability of failure. So that would just be the failure rate, whatever percentage that may be, times the cost, which is going to be the average sales per lab result. So long story short is you can estimate the cost of failure. And I don't think anybody's estimated that. And I think they maybe estimated that, actually, somebody's estimated that cost in California, but nobody's estimated that cost in Washington. And Washington has actually a lot less stringent regulations than California. So it'd just be interesting to compare the costs here in California here in Washington to California.
Okay, that is related. I've been putting together a data set. I was going to look at like THC, like over time, how it was rising and how that related to sales. Because I've been told that, you know, that's like the driving thing.
What's a driving thing?
The percentage of THC, like that's like a big selling thing, and going up. I'm wondering, is that like also driving sales up?
So just from the grapevine, I think, you know, some people are curious about that question. And so it's actually an easy research question to answer. I mean, you could do it more formally, but the real informal, quick way you do it is you would just take a regression of sales on well, I think that's where you would do the sales per lab result. So you would look at your independent variable or your dependent variable y would be the sales per lab result, and then your independent variables, your regressors, would be the THC percentage of that lab result. And so then you could actually just do an ordinary least squares regression, and you would just see, okay, what's the coefficient on THC? You know, your hypothesis would be that it would be a positive coefficient. And the question is, what would be the magnitude? Is the magnitude even significant? And then, like I said, you could then do you could do fancier things, like you could take the log of both sides. I mean, that would almost be a given thing. You know, take the log of both sides, see what and you know, you could do fancier regressions, but often just the ordinary least squares is pretty informative. It's a good place to begin. That's my recommendation. So.
Okay.
If you scrape that data together, I could show you how to run the regression. But essentially, like I said, the two data points you need are sales per lab result, and then you would actually need the actual, you know, THC of that lab result.
Right. So yeah, it's just kind of linking the data. There's, you know, the lab results link to the inventory, which links to the sales. And so that's like the inventory and the sales are huge data sets, and it's trying to get it all in, you know, into memory, or at least swapped out to disk, and getting that all to join together has been a challenge.
Yeah. So what are you going to say, Josh?
I was kind of wondering if you could split up the data sets that in a way that wouldn't hurt the performance of any predictive model. Like maybe yearly would be doable, since I think if you have years of data, since I think the year doesn't affect sales necessarily, but the month and day typically does.
I think the problem is, I could be wrong, but I think there's almost like unzipped. It could be like 100 gigabytes of sales data a month. And that could be wrong, but am I wrong, Charles? Or was it like about that long?
Yeah, it is around 100. Yeah, it's over 100 gigabytes of data.
Huh. Could you?
And I'm not sure if that was total or a month, but
I don't even know how you'd run analytics on that, on like anything other than like a server, unless you can make summaries of the data over time.
Well, that's my whole going down the Dask rabbit hole. It's that's supposed to solve that problem, and it probably does once you get Dask configured right. Um, and I also found that Dask runs differently. Dask and Pandas runs differently on my Mac than it does on my Linux box. So I've been discovering things by running experiments on each machine.
Well, it works, I guess. I've never used Dask, so.
you've got the right idea, though, Josh. Is essentially we're just trying to get like a time series of data, like summary data, metadata, out of this, and just leave the bulk of it there. We're just looking for daily totals.
Yeah. Huh.
But that's just sort of an ongoing project. But we're, like Charles has said, that's sort of the question on everybody's mind is how much does, THC affect sales? So, like, how much is like a 1% increase in THC? Like, what would that actually, like, how much in dollars would that change at the retailer?
Even if you did, if you had 0.1% differences in THC values and what we're able to get the sales data for those specific ones, then you could also do like a whole like 1,000 values of different percentages of THC at most every day and probably have a small amount of data compared to, was it 100 gigabytes per month? So that's also a pretty good measurement that you could do.
I kind of lost internet connection. Okay, I'm back. I lost connection there for a second. Okay, Josh, could you please repeat your last thought?
Sure. So I was thinking, even if you had 0.1% scale of the amount of THC in marijuana, then you had sale data with respect to that, with respect to each of those products, you could at most have 1,000 bins for each of those sales and then have that for every single day, and it would still be very small compared to the 100 gigabytes per month. And that would be 1,000 points at most. I don't think you can have marijuana with 100% THC. That would be ridiculous.
I think, correct, is sort of the point you're going on at. Are you just like looking for like observations that span like the spectrum of possibilities, or?
I think if you were saying THC is important for sale data, then that would be an important observation to get analytics out of. And if it's also time-based, then those two could be correlated as well, depending on the month. Like Seattle, you have seasonal affective disorders, so that you may have different audiences.
Ooh, you actually just hit on a good point. So that would actually, you're actually talking about panel data. So what you have is observation Y of IT. So you'd have sales of lab result I at time t.
Yeah.
So, and that's how you could improve the model. So essentially you would just the easy way to do it is just toss in a like a time effect. So just like a counter 0 to n or 0 to t for however many periods you have. Toss that in the regression, and you would control for time. There's maybe more elegant ways to do it, but I think time is a good factor, because that's actually something that I was looking at recently, was essentially prices in Oregon. So Oregon makes their retail and wholesale prices available, and so you actually see prices, go way, dip way down over time, and actually recently they're actually kind of trending up a little bit, believe it or not.
Yeah, I don't get to drive around very much right now, but I don't drive around very much. But before, I could remember, like, you'd drive down the street and you'd just see people with signs out, and and the price just kept going down and down and down. But I haven't seen lately if it's what people are advertising. And
Well, do you want to see real quick? That was sort of what I put together for today.
yeah,
So
cool.
here, I'll just show you real quick. So essentially, so here's just total sales in Oregon, and then here are actually if you want to just find it directly online, Oregon has an all-right data dashboard here. The problem is it's a little difficult to download data, but at least it's here. So data. So I'll actually push this to the GitHub here. So I'll push some links here to the Oregon sales data. I've got some of these prices open. So, and that's the other thing, is I'm sort of recording some of these by hand, essentially. But over here, you've got the Oregon data, and so you've got the wholesale and retail. So here's what I was sort of referring to. So if you see, like for concentrates at least, you've got the price, dropped by, almost 50%. And now it's sort of, for concentrates, hovering around $20 a gram, with maybe a slight uptick recently. Flour dropping from like $10 a gram, down to about $5 a gram, or more actually, like $4.50 a gram. And then now it's sort of rising above to about $5.50 a gram. So one thing that I was going to introduce to you and then start calculating, over this meetup and the next meetup was essentially inflation. And so, that's an interesting economic variable. And I don't think people have really looked at it that much in the cannabis industry. I mean, I'm sure people have to a certain extent. However, I don't hear too much talk about it. So, it's worth at least calculating it once just to see what's going on. So, essentially, we'll be calculating, the price today, minus the price yesterday, divided by the price yesterday. I've realized the way that we want to do this properly is actually take a weighted average of price based off of the amount sold. So you'll want, was there a question? Or?
Oh, inflation is interesting because that reminded me. I think I heard someone arguing that Bitcoin wasn't actually inflating necessarily if you took some metrics of inflation with respect to the dollar, because the total amount of dollars in circulation was getting larger, or actually just total amount of dollars available. But then it's hard to calculate the US dollars because is it available or is it in circulation or where is it?
Well, that's a good question. I hadn't thought about that.
Yeah, don't necessarily have a stable metric to compare this to.
So just in itself, of the Bitcoin series is probably inflating because the price today, depending on how granular you want to measure price, maybe monthly or something. It depends on the time span you're looking at. I think that would be an interesting thing to measure. One thing I would just point out is, I guess inflation is typically thought of as an aggregate of all prices. So you would be thinking of sort of it's typically a macroeconomic variable. I don't see any reason why you couldn't apply it to a single market.
I think you'd have to have something like a cost of living index, and if that went up, that would be I think that would actually be described as inflation by the legal definition, if I remember it correctly.
Exactly. So basically, what you're getting on here is like the basket of goods that the consumer has. So So if you go up here, you'll see, out of the total sales, let's say flour is, 60 million out of, 100 million. And then we'll just say concentrates is, 40 out of 100. Out of 100 million. So what we're basically saying here is, the consumer's basket, you're basically saying, your basket is, 60% flour and 40% concentrate. Sorry for the crude handwriting. So you've got 60% flour, 40% concentrate in just a consumer's average basket. So the way you would then measure the inflation of a a cannabis basket. So, for a consumer of cannabis, what's the inflation in their cannabis basket? Well, that would basically be, 60% times, 5.5. Sorry for the, and then you would just add, the 40% of which they're spending, 40% on concentrates. And then the concentrates is, about $20. So basically what you're saying, is basically at time T, your price is, 0.4. So your price at time T is like 5 plus 0.6 times 5. So, so that's essentially what your price at time T is. And this can be thought of as just a measure of like aggregate prices. And so then you kind of just see is, do you would expect prices to be rising over time gradually? Maybe the economy as a whole, I don't know what the inflation rate is off of the top of my head, but maybe like 1 to 3% or so. So it would just be real interesting to see what the inflation rate is in the cannabis industry. And like I said,
Interesting.
and you could almost do like a time series analysis, and you'd basically see like is there like a difference? You could basically see like, was there some sort of was there some sort of structural break in the market? Because it looks like things have kind of like stabilized, and like I said, they may even be kind of trending up. It's kind of hard to tell.
Yeah.
I think huge entry into the market, and that forced prices down. We have the same problem. We have the same problem with Chinese restaurants in this area, where there was the dim sum wars.
Really?
There are Chinese restaurants popping up like just like one right next to the other, and that forced prices down. And I saw the same thing with dispensaries, like they were just popping up everywhere. And so maybe at some point, right, the market's going to be saturated and you can't open up anymore. And but originally it caused prices to drop, and now I think it's probably stabilized. And especially with the pandemic, people are probably not opening up a lot of dispensaries, so prices are probably starting to stabilize, and they probably will start to rise again.
Exactly, and that's what you see, like. And that's why it'll be nice to like look at some statistics and like do some trends. But I mean, it does look to me that maybe starting in around June of 2019, things are gradual. I mean, prices are gradually trending up. But for the most part, it looks pretty stable. I mean, it looks compared to the prior 2 years. It's pretty stable, and in fact, that would actually be what economic theory would suggest. It would suggest that prices would for the most part stabilize over time with a moderate amount of inflation. And just to kind of show you a bit more of the economic analysis that would essentially go into this. So during this same time, keep in mind that, one would economics would suggest that, prices, even in the cannabis industry, would be affected by the interest rate. And essentially during this time, see, it's real interesting, right? So you see this graph, and things are kind of stable, but so it doesn't even really look like cannabis prices are even correlated. I mean, at first glance, with the federal interest rate. But once again, that's where we're going to use some statistics and see, what may be the relationship. Are they even correlated? And if so, to what degree? So long story short is the Federal Reserve's kind of, so the way that the Federal Reserve policy generally works is when the economy is expanding, they try to raise the interest rate as high as they really can. However, as they raise the interest rate, it sort of puts the brakes on the economy. And then whenever there's a recession, they basically drop the interest rate to try to stimulate growth. What's sort of a criticism, I think, of economists is they basically say that the Federal Reserve isn't really able to raise interest rates high enough prior to a recession. So, like prior to a recession, if they were able to get the interest rates up to like 4 or 5%, then when there actually is a recession, they can actually drop it sufficiently. Because here you see the recessions hit and they've dropped it to 0. But that's sort of the problem is when you drop it to 0, there's nowhere to go.
You could go negative. That'd be interesting.
Well, that's essentially what they do. They have to essentially use creative, or not really creative, but sort of technical monetary policy to sort of simulate negative interest rates. So to a certain extent, big banks during this time may actually be paying effective negative interest rates. But it's an indirect tool. So that's sort of the criticism is, it would be nice if they could just do it directly, and so they call it quantitative easing, where they give the banks sort of effective negative interest rates. But like I said, there's criticisms that it doesn't actually act the same as just moving the interest rate down. So long story short is it would be ideal if they could just, dip the interest rate down sufficiently, without hitting 0. But, to do that, they would have to have gotten the interest rates up a little bit. So,
yeah.
So long story short, that's what's going on at the federal level. But, here in the cannabis industry, we're going to see if this is even affecting prices or not. Because in sales, so here's sort of the economic theory behind what's going on, is you're basically saying that output, okay, so you're basically saying you know, output. We'll do inflation is red. Inflation and, you know, the interest rate. So you're basically saying all of these are sort of related to each other. Just sort of to color code this just so you can kind of see. So basically, we've talked in the previous weeks about essentially an auto-regressive process. So like this, right? So that's just like an auto-regressive process where, you know, what output depends on, you know, output from the previous period. Here we're doing a vector auto-regression. And so basically we're just saying, we're just going to estimate these three equations simultaneously. So we're basically just going to say, so basically we're just saying, okay, output today depends on output yesterday, inflation yesterday, and the interest rates yesterday. We will measure the coefficient on each of these. So we're not necessarily saying that output depends that much on interest rates, but we're going to find out. And similarly, you know, inflation depends on the amount produced, as well as, of course, you know, inflation from the previous period. And then economic theory suggests it also depends on the interest rates. And then this last equation is interesting because this is essentially leads us to, I wonder, so this is sort of similar. So this is, remember earlier we said the central bank, they set the interest function of the output gap and inflation. So basically, this is, you know, they call it like the Taylor rule. And this isn't exactly the Taylor rule. You actually have to, like I said, you'd actually have to do the output gap, which is what we're going to get to. So the output gap is what you would expect output to be minus output actually is. And if you're wondering what you expect output to be, we'll get to that in 1 second. Well, actually, let's just go ahead and get to that right now. So the Federal Reserve, they want to set interest rates, you know, based on what inflation they observe, their past interest rates, as well as what, you know, the total output in the market was. And ideally, they want to know what the output gap was, what expectations were versus what the actual were. Well, we can forecast with VAR models. So although we're, you know, using some economic theory here, the statistical model is atheoretical. You can apply it to any data set. as you see here, we're going to be packing in a lot of variables into each model. Also, we're going to be estimating 3 equations. So we're doing 3 equations times, if you just do an AR, and remember, and so these are, right, so you're going to do like an AR, X. So, so you may do like an AR, right? So if you wanted to do an AR6, where you're going to have 6 parameters times 3 equations. So, that's, no less than, plus you're going to have the constants. So, you're looking at like 21 plus degrees of freedom right there. So the long story short is you're going to need a lot of data if you really want to estimate a high order aggressive model.
What,
But
kind of wondering if you could do this for all the products in the market. I imagine that'd be a huge model. Have to optimize it a lot, but
so
seems like you could.
what I would do here is essentially, if you were doing that, what I would do is you do YT of I, and then where I would be your type.
I don't know. At the point where you're doing all the products, I wonder if you're capturing inflation and interest rate.
Well,
Yeah.
So essentially, like I said, so say like I, for example, let's say like I is flour. Let's say this is an element of like flour or concentrate. Great. This is getting a little messy. Let's just do this. Okay, so let's just say type element of F4. Okay. So, like I said, it just sort of dilutes the definition of inflation. I'm going to have to actually do a little research. So my expertise is microeconomics, and so I was sort of reaching a little bit for the. So this is sort of your standard macroeconomic model. It would. Yeah, I'll have to do a little research because I think you could. So maybe you could just do output of flour, and then just do inflation of flour prices. However, the way I would just approach this right out of the gate would basically you'd calculate a crude with no CPI, a consumer price index. And so that's basically like a weighted average of all your prices. Weight I. So, So this is how essentially at the ticket, and then you have a weight for each good, and then you have a price for that good. So here we're just saying
You're kind of breaking up. Josh, if you
Yeah.
turn off your camera,
Okay.
the bandwidth works better.
product type. So
yeah,
I'm going to actually
better.
put together a bit better. Say that one more time. Or,
You're breaking up a bit.
oh, so we have our basket is calculated. So basically, this is where we get our weights from. Can you hear me?
Yeah, if everybody turns off their camera, you come across much clearer.
Oh, sorry. I think it's just maybe a bandwidth thing. So maybe I can close some of these tabs. Okay. Can you hear me okay?
Yeah.
Yeah.
Okay. So just to sort of conclude with the explanation of this inflation real quick, and I'll tidy up these notes for next week when we actually calculate this thing. So essentially, you have the sales by product type, and you have the total sales. So we're seeing that, okay, consumers are spending about 60% of their money on flour and 40% on concentrate. So you can say basically somebody's basket of goods is going to be 60% flour and 40% concentrate. So that's where you get the weights from. And then you have the actual prices. So you have the actual price of flour, P of I, and then you have the actual price of concentrate, P of I. So then you then can calculate the CPI, which is basically, so this is the, consumer price index. And you can think of it, you may have heard of like index funds. And what an index fund is they basically take a weighted average of like a basket of stocks, and then you can invest in that basket of stocks through the index fund. So
S&P 500.
Exactly. So that's like sort of a basket of the top 500 largest companies, essentially, and it may be weighted. Like I said, I need to touch up on some things like that, but exactly. So that's an example of an index. And so the consumer price index is just an index of prices. So the actual number is like the nominal value is not that important so much as the direction. So what this, like the nominal value is, doesn't mean too much. What is important is inflation. And so that would basically be the CPI at time t, right? So basically this is the CPI at time t. So you would basically do the CPI at time t minus the CPI at time t minus 1 divided by the CPI at T-1. And that's how you calculate inflation. And our hypothesis is that it would be, 1 to 3%. And that's my hypothesis for this time frame. So that's my hypothesis. And next week we can actually use this data. So I must have saved it in some weird place, but I gathered the data from the Oregon state dashboard, and so next week we can dive in and basically calculate the inflation rate. Then, sorry for this mess. Then we'll actually estimate the VAR model, the VAR model, using output, sales, inflation, which is a function of price, and our third variable will be the federal funds rate, which will be our proxy for the interest rate. And we're going to see how much interest rates affect output and prices in the Oregon cannabis market. And the way we're going to see this through is we're going to essentially measure the output gap. So we're essentially going to use our VAR model from earlier and forecast output, inflation, and the interest rate into, for the remainder of 2021 and perhaps into 2022. So we know what we're forecasting. We know the purpose of forecasting. And so next week, we will be finishing up and we will forecast using this VAR model. So sorry that it was a little all over the place today. It needs to be a little more structured. So for next week, I'm going to structure the presentation a little better, and we'll actually get to the data crunching next time. I had a feeling the inflation was going to take just a little bit just to kind of get, just to explain what's going on there. But that's the crux of our analysis. And so next week we can actually calculate the inflation rate and forecast it forward for the cherry on top. But do you have any quick questions or anything, Josh? Or
not off the top of my head.
right. Thoughts or Charles or?
No, it was a cool presentation, and it'd be great to see next week when it kind of all comes together.
Yes, and so I started to put together some Python scripts just to calculate it, and like I said, there's a little bit more data to assemble, but all the pieces are there, and I don't know of anyone who's done this analysis before, or at least I haven't seen it. If you've seen it, then send it my way because I'm interested in this. But for next week, we can calculate it, or if you're ambitious, check out the GitHub, the Cannalytics, Cannabis Data Science GitHub repository, and you can get a head start. But essentially, we're going to forecast these series, and we're going to be enlightened, and we'll be some of the leading experts on cannabis prices in Oregon. So it'll be pretty exciting.
Okay.
All right, team. Glad to have you aboard, Josh. I hope you enjoyed it. Let us know your feedback, what you liked, what could be improved, and we'll take it from the top this week.
I'm mostly working on sparse neural networks, by the way. So
Neural networks.
oh yeah, I'm trying to develop a new layer in PyTorch. So I'd be good at doing, I guess, sparse versions of huge data sets. So like that whole market thing I mentioned. But for now, I'm just going to work on this thing for the most part, because I just want to get a little robot that can move around. Finally,
we've got huge data sets for you, so you may want to get in touch with Charles, because he's leading the front. He's spearheading this one, so definitely reach out, get in touch, and that's exciting. PyTorch is an awesome tool, so I want to see your contributions on that. So that's awesome.
Yeah, if I can get some, I don't know about the scale of data where it's hard to fit on my computer, but if I can get it streaming in some way, then I might be able to work with that.
Oh. Yeah, are you going? Have you attended any of the GTC conferences this week?
I have not. Oh yeah, that has been on my schedule. GTC.
Yeah, there have been some good presentations on PyTorch. There have been some really cool presentations on, self-supervised learning and robots, and
Oh yeah.
it's amazing, and it's free this year. So, and it's going on through Friday still. So that's where I'm spending all my time watching presentations this week.
I'll probably add some of those to my schedule then. Oh yeah. Tuesday, Wednesday, Thursday. Yep. Deep learning for autonomous vehicles, accelerating CUDA. I don't want to use CUDA necessarily because I got a ton of AMD GPUs. So.
Yeah. Are they in PCs or Mac?
PCs. But there's a Vulkan compute repository that I'm trying to work with, but that's got to catch up a bit.
Yeah. Yeah. TensorFlow is going to start working on the Mac pretty soon, like the next version that comes out. But yeah, I don't know about like AMD stuff.
Yeah. Really, they're working with Metal before Vulkan?
Yeah.
That's surprising.
That's been like a 2-year push.
Doesn't seem like a good move to me, to be honest. I mean, Vulkan should be able to support all GPUs, and Metal is just one very specific sector.
Yeah, I don't know. I think Apple pushed for it, and yeah, there was like Plaid ML, but I've never gotten that to work.
I'll just try to get Vulkan working, and then if that works well enough, the TensorFlow stuff would be obsolete because this would just work on so many more systems.
Yeah.
Question, Josh. Are you specifically trying to apply machine learning to the cannabis industry, or are you just spearheading machine learning just as is?
Right now, just spearheading machine learning as is. And honestly, I'm kind of just going to all the different meetups I can find on AI to see what different people are working on.
So it's so interesting. So my background was just in statistics and economics, and it seems I get the principle behind machine learning. Like, I think of it more as just framing the right problem. But I'm familiar with a lot of the tools because, a lot of the tools used are essentially statistic models. So I know the models and how to, estimate the models and use them. but actually framing the machine learning problem is something of an art, I think.
Yeah, it's data wrangling, right? I think that, like, I've looked at even biology, and that sort of framing the problem thing is still a thing there. Like, you have Fourier transforms in the ear, you have retinal ganglion cells that do crazy stuff in the eye, and like, as no matter how advanced you go, there seems to be data wrangling just everywhere. And then,
I may have to get you in touch with a couple people. There's someone that comes to mind who's working on a machine learning project, so may have to get you in touch with them. And then, if you're interested, Analytics is specifically trying to help laboratories and people do cannabis analytics. And it's open source, so if you wanted to find a way to plug in some machine learning uses, you're welcome to use that as your host.
that'd be cool. Yeah, the main thing I'm working on right now should just be able to do a bit more data. It's not really the data wrangling part, but yeah, it'd be interesting.
Yeah, and then you may have to shoot me whatever you work on in PyTorch, because, like I said, that's a tool that I've heard of, and I wanted to add it to my toolbox, but it's not in my toolbox yet. So always happy to learn.
It's pretty close to TensorFlow.
Same thing with TensorFlow. I almost got it into my toolbox, but it's still not in my toolbox yet. So I would like to add them both before long.
Okay.
But so perhaps one week, one of you, Charles or Josh, you're welcome to present at the meetup if you want about TensorFlow or PyTorch or some sort of machine learning application or tool. So you're welcome to, because like I said, I'm actually eager to learn about those topics.
Certainly when I get gas, I think gas will be a huge help to everybody. But it's just a lot of experimenting and finding and figuring out how to configure it right is, I think, a challenge.
Well, why don't you take some notes, Charles, and then when you get it up and running, why don't you let me know, and you can host a meetup, and then you could show us about Dask, and you could save us all a bunch of time by telling us all the tips and tricks for getting your configuration just right.
I will.
Yeah. I'm also curious about Dask versus Pandas.
Dask versus Pandas?
Yeah, is it different data scale or?
So Dask is basically, it works, it's basically a drop-in replacement for Pandas, but instead of like reading everything in at once, it delays the computation. And so like when you read a file, it's like instantaneous. But then when you if you want to look at the head of the file, it will, or the data frame, it'll take time. It'll compute it. But it also works in parallel. It'll do a lot of work across multiple threads, where Pandas is single threaded.
So it's optimized Pandas.
Yes.
And that it's almost like the right tool for the right job. So I think it sounds to me like the perfect tool for. So basically, on the very first meetups, we started to try to get into this Washington State data. So Dask is sort of it sounds like the tool for that job.
Yeah, and then if you have multiple machines, it distribute. It'll use the memory it'll use the memory across multiple machines to distribute. So.
Could potentially use it in production to do some interesting things.
Yeah. But you can use the same code on a laptop as you can across a cluster. So it automatically scales for you, or at least that's what they claim.
Well, I think I'm gonna go ahead and head on out myself. But it's been awesome talking with you guys about data science. As always, it's awesome to find like-minded people to talk about data, machine learning, what have you. So it's just fun.
Yeah, this has been a great meetup.
Definitely.
Yeah, it has.
All right, guys. I'm gonna go ahead and head on out. I've got a full agenda today of things to accomplish. But for next week, we can talk more machine learning. I'll have a tidier little demonstration of how to do inflation, and we can take it from the top.
Okay, great. See you next week.
All right.
Yeah,
Have an
see ya.
awesome week. Right, bye now.
Bye.
Bye.